So this next section is a big one in terms of the number of commands we cover. We talk about at least, 4, maybe 5 different commands. The thing that binds them all together is that they help you either undo changes or go back in time or view changes from earlier. But there's not just one thing we talk about. There's not just one command. So compared to other sections, at least other recent sections where, it was like git merge for the whole section, or git branch the whole section, or git diff. This section is a motley crew of different commands. And a lot of them are good to know about for sure and are useful at times, but they are not things you use on a daily basis unless you're like constantly messing up and constantly needing to revert or reset your work and undo commits, which personally doesn't happen to me like daily. Certainly I make mistakes or I want to undo changes, but not as much as I want to make commits, for example, or make branches. Anyway, we're going to start by talking about checking out commits and something called detached head and how to get out of it or how to fix it. It's not really a problem, but recognizing what that means. And then we'll talk about discarding changes with git checkout. I'll say that's important. Git restore is important. Git reset and git revert. Very confusing, right? Restore, reset, and revert. They all kind of sound like they might do the exact same thing. So they're all going to be marked, or I just marked them all as important. As I've mentioned, when you need them, they are critical, but you may not need them all that much. I want to refrain from putting everything ever in critical. I mean, it's in this course because it's worth knowing, but these topics in particular, I'd say just don't come up as much as the stuff over here. So definitely don't skip this section, but because there are so many different commands, I have a feeling it could be a little bit intimidating. So keep that in mind as you're learning them, right? You don't need to commit them to memory, or you may not remember them as easily just because you don't use them as much. Okay, let's get started with all these similar sounding commands. Here we go. All right, so the first of many different commands we're going to see in this section is actually one we've seen before, git checkout. So when we learned how to first switch branches, I used git switch. That's what I showed you. It's the newer way of doing things, but the long-standing way of switching branches is using git checkout. But also, git checkout does a lot of other things. So in this video, I'm going to show you one of those other things. Just as a reminder, a lot of people think the git checkout command does too much, which is why new commands were added, including git switch and git restore, which we'll talk about later on in this section. Okay, so if we use git checkout, but rather than checking out a branch, we instead check out a particular commit hash, like I've done here. Remember, we can view these commit hashes using git log. If we run this command, git checkout, and then a commit hash, something quite peculiar happens. We're going to see this message that sounds very bad, detached head. You are in detached head state. You can look around, make experimental changes and commit them, and you can discard any commits you make in the state without impacting any branches by switching back to a branch. Okay. So first of all, that sounds horrible, detached head. It's not a bad thing. We'll talk about what exactly it means, but first I want to demonstrate this. So I'm going back to our first little repo, the Great Gatsby novel that I'm writing, my first novel. If you recall, we just have a single branch. I'm on master, so that's all that we have. And we have a bunch of commits. Let me do one line here. So we started with an outline, and then I did chapter 1, and then I split chapter 1 into 2, chapter 1 and chapter 2. Then I renamed the character of Gatsby to Catsby, and then I added a mood board, and I did a bunch of other stuff. Well, let's say I want to go back in time to when, I don't know, what would a good place be? Maybe when I renamed Gatsby to Catsby. So I want to undo that, or at least I want to see what things looked like back then. Right now, in my files, there is no Gatsby. It's Catsby here. If I look at, the characters file, where are you? Here we are, J Catsby, chapter 1. If I did a search, we would find Catsby in here and not Gatsby. There we are. All right, so if I want to undo that, I want to go back in time. I can take this commit hash, which this is actually the abbreviated version. It's the first 7 digits for each one of these commits, and that's really all that Git needs. But I could also provide the entire thing if I just did git log and didn't do the abbreviated versions. So I could scroll down and find this commit hash here, or just provide the first 7, 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to copy that. And now, just going to make sure I don't have any changes on here. Okay, good. I'm going to go check out that commit hash. Git check out this old commit. And this is where I see that message. You are in detached head state. You can look around, blah, blah, blah. I already read that. So let me show you a couple of things. First of all, if I type git log, let me do one line. We only have, 5 commits that are showing up right now? Because I have jumped back in time. I've traveled back to this commit. I don't know how many commits ago it was, 6, 7, 8 commits ago. And there's only 5 commits at that point. This is where we are. Also, if I take a look at the files, well, I'm an idiot because I went back to the commit where we renamed to Gatsby. I wanted to go back to the one before where we were still Gatsby. So we see Gatsby is still everywhere. Okay, well, let's pick the commit before. So before we rename Gatsby to Gatsby, I can go to this commit for F1B and do the same thing. Git check out that commit. And I'm still in this detached head state. If I type git status, you can see head detached. And if I take a look now, Gatsby. Gatsby is all that we see. Do I have another example? Here's Gatsby. We don't have Gatsby at all. If I type git log, now we only have 4 commits. Okay? So I've jumped back in time, but don't fear, I haven't lost all of the other work that I had on the master branch. So what is this detached head? Well, as we've learned earlier, but I'm just going to review, normally head points to a particular branch reference. Are you on master? Are you on bug fix or new feature, whatever branch you're on? Head points to the branch reference. And then the branch reference itself points to the tip of a branch, the most recent commit on a branch. So if I'm on the master branch, head points to master, and master points to some commit. If I make a new commit, master updates to point to that new commit, but head still points at master, right? Head is still just pointing at that branch. If I switch branches, I go to bug fix, head switches to bug fix, but head is still pointing to a branch. And that's really the main takeaway so far. Head usually refers to a particular branch reference. It does not refer to a commit. Head is not pointing at this commit or that commit. Head is referring to the branch that we're on, and the branch reference points to a commit. So now back to this detached head thing. Look at all those detached heads. I manually detached those just for this slide. Anyway, now when we check out an earlier commit, what we're doing is actually changing head to refer to a commit. So in this case, I'm just going back 1 commit. Head points directly at that commit, not at a branch reference. So it's kind of a weird state. It is not normal. It's not bad, but we can't always do the same things that we could do if we were on a branch. So we're not on a branch. We're just floating around. We're a detached head. So I can just quickly show you what this looks like. If you recall, I actually showed that we can look at head inside of this .git directory, which is where all the Git stuff is stored. We can look at head. And earlier, when I first showed this a couple sections ago, we saw something like, I think, refs, heads, master, or oldies, or whatever branch we were on. But right now, I'm in detached head, and head is actually referring to a commit, the particular commit that I'm on, right? This commit. And that's abnormal. We're used to it pointing to an actual branch reference. Anyway, we are in detached head at this point. In the next video, I'm going to talk about what we can do here and why this could be useful. Okay? So right now, we've gone back in time, but we're kind of just floating around at some old commit. Next up, I'll talk about how we can branch off from here or undo things. So that's coming up. So now let's talk about what we do or what we can do in this detached head state. So in my repo, I've gone back to, what is this commit again? For F1, split chapter 1 into 2 pieces. I'll also show you in Git Kraken. This is where I went back to. It shows me head is pointing at this 1 commit. Master branch is still all the way up here, that branch reference pointing over here, begin chapter 3. There's 8 commits or so in the meantime, or in between. But I am now just looking at this split chapter 1 into 2 pieces commit. Okay, so one thing that I can do is just poke around, examine the contents of the old commit, view the files, maybe copy something, and then bring it with me somewhere, we can see that all my files have been updated to reflect the fact that we're all the way back here. So I can, I can see Gatsby everywhere. I don't see chapter 3. There's work that is missing because I've gone back in time. So if that's all I wanted to do, great. Now, if I want to go back to where I was, I want to go back to master, all I need to do is switch to a branch. So if I have a detached head, I can switch back to master, git switch master, or git checkout master, and we're reattached. So I can show that. We've got only one branch in this repo, so master. I'll just switch back. So right now, I'm in detached head. Now if I do switch master, git switch master, you can see I'm not in detached head. We're back where master is, right? Head points to master. If I type git log, we can see we have all those commits again, and head is pointing to that master branch reference. So nothing changed. We didn't mess up anything. We simply went back as an observer. We took a look at what happened all those commits ago. We time traveled back and then time traveled forward. But if I wanted to go back, let's say to where I finished chapter 1, and then I wanted to split off and try a new version of chapter 2 and chapter 3. Basically, I want to get rid of all of this work. I'm not going to delete all of that work, but I'm going to try making a new branch that doesn't include any of this. So I'll go back in time, maybe to this commit right here, whatever this hash is, and then I will branch off and do some stuff on that new branch. So I'll make a branch based upon this position, this particular commit. So I won't lose all this stuff. I'm just going to make a new branch without it. Okay, so that's the third option, really, I guess, for what we can do here. Create a new branch and switch to it. Now I can save changes, I can make commits, because head will now be attached to a new branch. So let's go back, let's pick one of those commits. Let's go to when I finished chapter 1 before we had chapter 2. So I'm going to copy that commit hash. Make sure I don't have any unstaged changes and nothing to commit. Great. And I'll check out that old commit from a long time ago. Once again, detached head. We can see where I am. I'm all the way back here. Now what I'm going to do is make a new branch. So just like I make any other branch, I can make it first, git branch, blah, and then switch to it, or just do it in one go. What should I call this branch? Let's call it, chapter 2 redo. Like that, okay? So I made a new branch and I switched to it. And just like any time we make a branch, that branch is based upon head. And at that point in time, head was this commit. So now we have a new branch here, chapter 2 redo, and I'm reattached. Head is pointing to an actual branch reference. We're not in detached head. I type git status, and we can start doing more work. So my files still look like they did when I was in detached head, but now I am reattached. So I could make my own version of chapter 2, right? Chapter 2.txt, and just put some random stuff in here. Here's my chapter 2. Maybe I want to, I'll just leave it at that, I guess. Maybe I'll delete all of chapter 1. I'll empty that out. Whatever I do, git status, I'll add those changes. I'm on this branch, chapter 2 redo, and I'll do something like, start second stab at chapter 2. So now I have this new commit, and it only exists on my chapter 2 redo branch. So this branch has the first 3 commits from master and then a whole new one where I branched off and tried a completely different version of chapter 2. I don't have this history, but it's still there, and I can just switch back to master, right? So this is what I'm looking at here. Chapter 1 is empty. Chapter 2 is almost empty. There is no chapter 3, but I can switch back, git switch master at any point, and all that stuff is restored. I've gone back to where we were before. Okay, so that is pretty much it for checking out previous commits. Git checkout, and then a commit hash will take us back, but we'll be in detached head. We can poke around, we can switch back, go back to master or whatever branch we want, or we can create a new branch based upon the particular commit we've time traveled back to. Okay, Okay, so we saw that we can check out a particular commit using a commit hash, but there's another way in Git that we can reference other commits. We can reference things based upon head. The syntax is it's a little weird, but it looks like this: head and then a tilde, which is usually above the tab key, and then a number. So head tilde 1 is actually going to refer to whatever commit comes before head. Think of it as head minus 1. Head tilde 2 is whatever comes 2 commits before head, the grandparent commit. So if this is where head is, if I check out head tilde 1, it's the previous commit. Head tilde 2 is this commit. 3 is this one. So I don't use this all that often, but sometimes if you have a reason to reference, what you did in the last commit, and you don't want to go look up that commit hash, you can still very easily reference it with head tilde 1. So I'll show that very quickly. On our master branch, let's just take a look. So we've got begin chapter 3, that's where we are right now. If I just want to go back one commit, I could copy this, right? And then check that out. Or I can do this, git checkout head tilde 1. Not 21, just 1. And once again, we're back to detached head because we checked out a particular commit. This is just a different way to reference that commit, right? We just said the previous commit, but it's still a commit. We're not on a branch. And we see that here, head is now pointing to this commit, add headings to all files. So before, head was pointing to master, which is still pointing to this commit. Now head is one before. And what we see in our file, we probably won't notice a whole lot, but there's no chapter 3. That is the difference. Chapter 1 and chapter 2 are here, but chapter 3 was the next commit. It still exists on master, of course. So from here, if I want to go back one commit again, I can just do the same command, git checkout head minus or tilde 1, because head is now right here. I can still reference one commit prior. Okay? And now we go back one further. So there we are. Head is now here. And we can see we don't have those headings in my files anymore. Chapter 2, chapter 1, they used to have a heading up top. And that's kind of all I want to show. Of course, I'll switch back to master now. Git switch master. And now we have those headings back, and we have chapter 3 back. So we're back up to date with the master branch reference. One other thing that we can do to get back to the branch we were on. So let me try and explain that in a better way. If I check out some commit, I go into detached head. Right now I'm on master, right? So if I check out head tilde, I don't know, let's go way back, like 8. We're way back here, this commit here. Okay, now if I want to go back to where I was, I want to leave detached head, one option is to just remember what branch I was on, master, and go back to master, git switch master. The other option is git switch with a dash, and that will just take me back to whatever branch I was on last. And that happens to be master. But I could show a different example, right? We have this other branch. I already forgot the name. What is it? Chapter 2 redo. If we check that out or switch to it, either one. Okay, that's where I was. Now I'm going to go back, git checkout head. Let's do tilde 1. Okay, so I'm on this branch. I'm going to go back one commit. Okay, and now I just want to leave detached head. I don't remember what branch I was on, or I'm just lazy. I do git switch dash, and it takes me back to where I left off. Okay, that's all I wanted to show. Okay, so on to another use for the checkout command. We can use git checkout to discard changes from a file, basically to revert back to whenever we previously committed. So I'm going to demonstrate this in the next couple of commands. There's restore is another command on a very boring, stupid repository that will make it very clear how this works. So I'm going to just I already have a repo actually, or a new folder called undoing stuff. It's not a repo. I'm going to init. And then I'm going to make 2 files. And they're, again, very silly. One will be called, how about cat.txt, and the other will be dog.txt. Okay, so 2 files. And then I'm going to add my first commit, git status. Okay, git commit, add cat and dog files. Then in both of them, going to open them up over here. I'm just going to write first commit and make a commit. And then I'm going to do second commit and make a commit. Basically, I have a record in 2 files. Every commit I make, I'm just going to say first commit, second commit, third commit, and so on. And this will make it easy for me to demonstrate when I go back in time, oh, we're back to first commit or second or third. So let's do that here. Git status, git add dot, git commit, first commit. Technically, it's our second, but I'll call it first commit. And then I'll do the same thing. Second commit. Okay. Git add dot, git commit dash m, second commit. And I'll do it one more time. Third commit. Third commit. Git add dot, git commit dash m, third commit. Okay, very boring, like I said, and trivial, stupid. But we have 2 files. Both of them have 3 lines. We added 1 line at a time in a commit. Now, what I want to show is that we can use git checkout with head and then a file name or multiple file names to revert changes or to discard changes that we've made back to whenever we last committed. So let's say that, I'm working and I accidentally type a bunch of stuff in here and I save and type a bunch of stuff in this file too. And I save. And of course, over here, git status, we see, oh, I've modified those 2 files. If I don't want to commit that, if that's a mistake, one option is just to manually delete that, right? Delete that, delete this. That's fine. But if we have a ton of files where I've done work and I just want to get rid of all the changes I've done, I can do it using git checkout head. So again, silly, but this is a demonstration of it. So I have this extra stuff in both of them. The last commit I made stopped right there and right here. So if I do git checkout head and then a file name, how about dog? I'm telling Git, take whatever the contents of dog were at head, right? Because head is different from where I am right now. Head is pointing at that last commit. Well, it's pointing at master, which is pointing at the last commit on the master branch. So head is still referencing this, and this new stuff is going to go away. And there, it's gone. Now cat.txt still has that stuff. But if I do git checkout head and then cat.txt, that's gone as well, right? Okay. So that's one way of doing it. Another option is to use the shorter version, git checkout dash dash. Instead of typing head and then the file or files, we want to revert back to head. So if I do a bunch of work again in this file and in dog, I could even get rid of that, just screw everything up. And then I realize, oh crap, this is a disaster. I want to undo those changes, but I can't. Or maybe I could just do Command Z, but let's say I can't. Over here, I could do git checkout head or just git checkout dash dash cat. I'll do both of them and dog. And we're back to where we were at head, where head is still referring to this commit. Head is always, unless we switch branches, it's going to point at this master branch, and that master branch doesn't move until we make a new commit. Git log, and this is where head still is. All right, so to recap that, git checkout, head, and then a file name or multiple file names will reset those files' contents back to whatever it looked like in your last commit or when you last committed, aka where head is still referencing. And then there's a shorter version, git checkout dash dash does the same thing. What's extra confusing though, or kind of annoying to have to teach you, is that there's a whole new command that also does the same thing and more. And that's what we're going to learn in the next video. It's called git restore. All right, so now we're on to a new command, git restore. And this is actually a new command to Git. It's pretty new. It's not all that well known. So there's a lot of existing tutorials and videos and courses that don't mention it at all. Git restore takes some of the burden away from git checkout. It does, remember how I've said this a couple times, git checkout does a lot of things, and git switch alongside git restore, they both were introduced to try and take away some of that stuff from git checkout. So git checkout still does all that stuff, but now we have standalone commands git switch to switch branches and git restore that helps with undoing operations. As you've seen already, we can use checkout to switch branches. We can use checkout to check out earlier commits. We can use checkout, as we just saw in the previous video, to undo or discard changes. So it's kind of crazy. But restore is the new command. It sometimes honestly feels a bit clunky to me, but I'm going to show it to you now. So the first thing we can do with git restore is discard changes that we've made in a repository since the last commit. Basically the same thing I showed you in the last video. So if I make some changes in my file, let's say dog, I add a bunch of stuff again, I delete all of this, right? I write like whatever that is, dog. Okay, I make a bunch of changes. I haven't added or committed them. I type git status, right? I've modified dog, and I realize, you know what? I don't want any of that. I can type git restore and then dog.txt. I don't even have to reference head or anything like that. Just git restore and a file name, and it is going to restore my file, dog, back to what it looked like at head, where head currently is, at the last commit that we've made. So here we go. And there we are, dog.txt, back to where it was. So this is the same as what we did earlier, git checkout head dog.txt. It's just a little bit simpler. And then the other thing we can do is actually reference a particular commit and go back, so I could restore the contents of my dog file or my cat file or whatever I want to what it looked like 2 commits ago. So I'll show you that. This is why I said it's kind of clunky. We have to use the -- source option. So git restore, and then we specify a source. The default source is just head, as we saw. But we can specify a different source using -- source, and then either a commit hash or this, what do you call this? This syntax, head ~1 or head ~2 and so on. So let's try this out. It doesn't matter if I have stuff in here or not, but let's say I screw it up a lot. And I want to restore the dog file back to, I don't know, if this is head ~1. Let's go all the way back to here. I want to restore it to this commit. So this would be head ~2. This is head, back 1, back 2. So I can do git restore, -- source, head ~2, and then the file name. And whatever is in here, I have unstaged changes. I'm going to lose them, which I don't think I made a big enough deal about earlier, but those changes are gone. If I haven't added or committed those changes, if I lose those changes, Git has no record of them. So only use this if you are comfortable truly going back and getting rid of uncommitted changes that you have at the moment. All right, so here we go. Restore the contents of dog.txt to what it looked like 2 commits prior to head. And there we are, first commit. Now, that doesn't move us, right? If we type git status, we're still on master. If I type git log, we're still here on the last commit, the tip of the master branch. So we haven't gone back in time. We haven't time traveled, no detached head or anything. But dog.txt has been modified. So if I don't want that, if I want to go back to head on that file, I can still do git restore dog.txt. And now it goes back to the most recent commit. So we still lost, if we have a bunch of other stuff, that's going to be gone unless I add and commit that. But I can restore back one more time. Let's go git restore, and then I'll do it to both files. So -- source, head, and then I believe it's ~3, and then I'll do cat and dog. Oh, no, I guess there is no head ~3. It is, it's head ~2. Well, here we are, first commit on both of them. And then if I really didn't want to do that, or let's say I want to take cat back to where head is right now, git restore cat. And there, cat goes back to where head is. Dog is still back 2 commits prior. Okay, so again, this is a very silly example, but I wanted to do something obvious where we knew this came from the first commit, this came from second, this came from third, and this, having 2 files makes it easier to demonstrate. So there we are. That is using git restore, at least one use of it. In the next video, I'll show you another use of git restore, but so far what we've seen is that basically this is another way of doing what we've already seen how to do with git checkout, where with git checkout, we have to specify head and then a file name, and checkout does a million other things, so it's confusing. Restore is a lot more narrowly focused. It does really, well, I guess 2 things, but so far we've seen 1. And by default, it will restore based upon head. We don't have to provide that, or we can provide a source with -- source and then specify a commit hash or use this syntax. Okay. So the second use for git restore is to unstage files that we currently stage. So if we made a mistake, we stage something, it's going to be included in the next commit, and then we decide, we really don't want that, we can unstage it using git restore and then -- staged in a file name. So I'll demonstrate this. Let's restore back to head. So we'll just do git restore, git restore our files, cat and dog. We'll go back to first, second, and third in both of them. So now I'm going to make a new commit in here, 4th commit. So I'll just put that in both of them. And for the sake of this example, I'm going to make a file. I'll call it secrets.txt. And in here, I'll put something like, I don't know, API key equals some API key, and then credit card number equals, and then some fake, I don't think that's the right number of digits, but let's say that's your credit card number. Okay, then I forget about this file, and I'm ready to make my next commit. So I head over here and I type git add dot, and then I have a horrible sinking feeling. I type git status. I realize, shoot, I did not want to stage my secrets file. I don't want to include that. Now, ideally, I would have a git ignore, and it would include that file. But still, there are times, if you've done a lot of work and you need to split your changes up into a couple of commits, you might add a file that you don't want to stage. You might want to remove it. That's what we're doing here. I want these 2 to be included, right? I want 4th commit, 4th commit. I want that to be included, but I want to unstage this. So to do that, git restore -- staged, and then the file name. So here we go. Git restore -- staged secrets, not stages, staged. Okay, type git status. And now it's not being tracked, right? Git doesn't really care about this file anymore. It's at least not staged to be included in the commit, but the file has not been changed. So we didn't delete it or reset anything in it. It's just not staged for the next commit. So now I can make my commit 4th commit. Git status, still, it was not included, and it's still there, just waiting for us to stage it, or ideally to ignore it. So that's kind of confusing, right? The 2 purposes for git restore. One is to unmodify a file or files, and the other is to unstage file or files. Fortunately, if you use git status, Git will tell you at any point. It reminds you how to do both of them. So, for example, if I stage a change, which right now I don't have anything, but if I do stage that change, git add secrets.txt, and I type git status, it tells me right here, this is going to be committed. If you don't want that, use git restore -- staged, and then a file name to unstage. Because honestly, I struggle to remember this. I don't have to do it all that often. Thankfully, git status tells us. So, we could just copy that. Great. And then the same thing, if I change one of my files, I put some stuff in there, I delete it. Great. Git status. It says, hey, you modified that file. And it also mentions to discard the changes in the working directory, use git restore and then the file name. So I'll do that. Git restore cat.txt, and we're back to where we were. So you don't have to remember it at all times. You can just use git status. It will remind you what to use. It does not show you in git status, though, that you have this option, right, to specify a different source. Not as common, but this does allow you to reset the contents of a file to what it looked like 10 commits ago if needed. So you can use that -- source. It defaults to head, as we've seen. Okay, so that's git restore. Okay, so we just saw git restore. Now we're moving on to a similar sounding command, which is git reset. The git reset command will reset a repository back to some particular commit. So if we're working on, let's say, the master branch, and then I realize that the last 3 commits that I've made were not supposed to be on the master branch, I screwed that up and I wanted to put them on a different branch and I want to remove them from master, I can do that. I undo those commits using git reset. And there's two flavors, two varieties I'll show you. There's regular reset and then a hard reset. And we're going to start with, I guess, the plain old regular reset. I don't know if anyone calls it that, but that's what I'll call it. Plain reset. It looks like this: git reset and then a commit hash. And this will reset our repository back to whatever that commit hash is. Let me demonstrate this with our really boring cat, dog, first, second, third, fourth commit. I'm going to go, let's delete this secrets file just to make our lives easier. Okay, so it's gone. Let's make a mistake or do something in here that we just want to undo. Let's say it's that. And then this one over here, I delete that. And then I'm going to save this. And then I'm going to make a commit accidentally, which I'm doing on purpose, but we'll pretend I don't actually want this commit. Git commit -m mistake commit. Okay, so here's what we have now. First, second, third, fourth, and then mistake commit. And you can see, I added those 2 lines, and then I deleted this in the dog file. Anyway, we've screwed it up. And maybe I do one more commit that's even a further mistake. Why don't I don't know, add a happy face. Same thing over here. Git add dot, git commit -m, another mistake or another bad commit. Okay, so now I can use the git reset command if I find a commit I want to go back to. So git log, let's just do 1 line. If I want to go back to 4th commit, I can reference this particular commit hash, or this is the first 7 digits, copy that, and then git reset and that hash, just like this. And what happened? Well, you might think those changes are gone, but they're actually not. Those changes are still here. Doesn't that seem like they should be reset? No, because all that we did was perform a basic or a plain reset, and that removed the commits, but the changes are still in our working directory. So I can get rid of those changes and I can, undo stuff in my local files. But all that we did right now was tell Git to get rid of some commits. Go back to this last commit. That what was it? 4661. So in Git's mind, that's where the history stops. There is no commit after that, right? Git log. I'll just do 1 line again. That's the last commit it has, but it kept those changes in our working directory. So here's a diagram to show that. Let's say we make a commit and we realize, we don't want that commit. So to undo it, if we use git reset and a commit hash to go back to this one, those changes are still in our working directory. We don't lose the changes, we lose the commits. However many commits there were between head all the way back to this commit, it just happened to be 1. So in our case, we undid 2 commits over here, right? There were 2 commits. One was mistake, and the second was called bad commit, I think. But we still have the changes. This can be useful if you make some commits on the wrong branch. You want to keep that work, but move it to another branch. So we reset, right? We lost those commits on the master branch, but now I could take these changes with me and make a new branch. Git switch -c, I don't know, bad stuff. And on here, I can add and commit those changes. Git add dot, git commit, add bad stuff. I don't know, it's stupid. So now I have this branch that I've made that has, these mistakes, the stuff that I presumably don't want. And now I can go back to master, and things are how we want them to be on master. So I took those changes with me over to the new branch. I added and committed them on the new branch, and then went back to master without those changes. Okay, so hopefully that was clear. Reset, git reset with a commit hash, removes the commits, but it does not remove the changes from your working directory. So you don't lose that work, you lose the commits. The alternative is a hard reset, which is the same command, but with --hard. And when we do a git reset --hard with a commit hash, what will actually happen is that we lose the commits, Git undoes the commits up to this commit hash, and the changes are removed from our working directory. So if you absolutely know you want to get rid of some work and get rid of the corresponding commits, you can use --hard. So you can reference the commit hash, or you can do things like, we've already seen head ~1 or ~2 to go back relative to where head is. So on a diagram, if I wanted to undo this and get rid of those changes, git reset -- hard, the commit hash that we're going back to, those changes are gone. So I'll do a quick demo of that. Let's go back to master, git switch master, and let's make another bad change. So we'll delete 2 of those in dog, and then we'll add a bunch of stuff in cat again. All right, and then I'm going to add and commit that on master. Git commit, undo this commit, please. Okay, so a regular git reset, as we saw, would keep these changes in our directory, but it would remove a commit. I am going to undo that last commit, so git log, let's just get the commit hash. I'll go back to this one, third commit. So that means I will lose this commit and this commit, and I'll lose the corresponding changes I made in both of them. So you want to be careful with this, obviously. You don't want to go around just resetting hard all the time, but I'm going to do it here. So git reset -- hard commit hash. One more time, this is what we're looking at. Undo this commit, please, on master, fourth commit, third, second, and so on. Here we go. Okay, it says head is now at this third commit. As you can see, here's master. We no longer have that commit on master branch. We lost 2 commits on the master branch, 1 line. Now we just have 3. And in my files, they both are reset back to what they looked like. They have the same contents that they did when we made this third commit. We reset them back. Okay, so that's kind of all there is for that. I guess I should mention, right, this is on a per branch basis. So if we go back to my diagram, we still have that fourth commit over on bad stuff. It's not like we remove this commit from every branch ever that knows about that commit. It's still there. If I go to bad stuff, git switch, bad stuff, do a git log, we still see fourth commit. Anyway, so that's reset and reset hard. Okay, we've made it to our last command for this section. Another similar sounding command, git revert. Yes, we have restore, we have reset, and now revert. They all kind of sound like they do the same thing. Revert actually does something very similar to reset. It has to do with undoing changes from a commit, but there's a very important difference. So both revert and reset will undo changes from a commit, but the way that they accomplish it is different. As we saw with reset, reset removes commits entirely, and it moves the branch pointer backwards as if those commits never occurred. They never existed in the first place. Revert does something different. It actually makes a brand new commit, and in that new commit, it undoes the changes from an earlier commit. So it still helps us undo changes, but again, it makes a new commit that basically says undoing changes. Instead of just deleting everything and deleting history, removing commits, that can be a problem if you're collaborating with other people. So at the end of this video, I'll explain why you might use revert or reset, vice versa. Okay, so let me just visualize that for you. So here is a diagram of using reset, where if we reset back 2 commits, we lose those commits entirely. They're gone. Whereas if I use revert, let's say that I made a mistake on this most recent commit. It's already been committed, and I want to remove that change or changes, but I'm going to revert. I end up with a new commit, and this new commit effectively undoes this one. So I revert a particular commit hash. This is the commit that I'm reverting. It doesn't go away. It's still there in the history of my repo, but the changes from it are gone, hopefully. So let me demonstrate this. I'll go ahead and do a really simple example. I'll make a bad commit. Bad commit. And same thing, I'll do it over in cat. Okay, so I have 2 changes, and I haven't made a commit yet, but I'll commit them now. -a-m, make a bad commit. Okay, so I have this bad commit. We can ignore this other branch, but on master, I have bad commit. And I realize, I really did not mean to make that commit. I want to get rid of it. Well, in the last video, we saw to use reset, but I actually don't want to reset. I want to keep a record of this commit, but I want to undo the changes. So I'm going to use revert. So this is the commit I want to revert. I can use the whole, head tilde1 tilde2 type syntax, or I can use a particular commit hash. So I'm going to do git revert and then this commit hash right there. Okay. And it opens up my editor, right? Because it generates a new commit, just like when we merge. It generates a commit when we merge, or sometimes if it's not a fast forward. When there's a merge commit, we need to provide a message. So the default message is revert, make a bad commit. This was the commit that we reverted, right? That was the message, make a bad commit. So it's reverting that. Now we can put other stuff in here, maybe an explanation why we're reverting it, what's wrong with that commit. But I'm just going to close it. And let's see what happens. If we type git log one line, that bad commit is still there. But now we have this new commit at the tip of our master branch, and that new commit reverts the one before it. If we go back to our editor, we can see that the 2 changes we made are gone. So we still have the history preserved of that commit, but its changes have been reverted. So why would you do this? What's the reasoning? Why not just reset? Well, it has to do with collaboration, which we haven't really talked about yet. But if you're working on a team with other people and they're all on different machines, you don't just all work on the same laptop. If other people have copies of that commit, if everyone else had that bad commit on their copy, and then I decided to get rid of it using reset, that can cause some serious problems because I'm undoing history that other people have, and that can be difficult to reconcile. So instead, what we usually would do is use revert, and that will make a new commit, as we've seen, and I can share that new commit with everyone. Now, potentially, I might make a mistake and make a commit I want to get rid of, and I haven't shared it with anyone else yet. Then it's fine to use reset. Nobody ever knows. They don't have it on their machines. But as soon as collaborators have a commit, if you're trying to get rid of those changes, it's better to use revert. So here's a demonstration, some diagrams. I'm working with 2 friends, and then here's my local version of my repository. So I'm using just commit numbers here. So everybody has 1, 2, and 3, right? 1, 2, 3, 1, 2, 3. And also, my friend down here has done more work. She has commit 4 that she's worked on, and I don't have that. And neither does our other friend. Anyway, I realize I want to get rid of those 2 and 3 commits. I use reset, and that's a problem because I've already shared that with my friends. So it's going to be very difficult to reconcile their code with mine because they already have those commits and they've been working on top of them. I altered the history that they already have. So instead, what I should do is revert and make a new commit that undoes the changes from some other commit. And that is easy for me to share with them and for them to reconcile. So it's kind of a simple explanation because we haven't talked about collaborating and sharing code and, pushing and pulling and GitHub and all of that stuff. But that's coming up very soon. I think we're pretty much at the end of sort of the core Git functionality, and we're going to start talking about GitHub. The last thing I'll say about the revert command is that sometimes reverting a commit can result in conflicts where you need to go into the file just like any other merge conflict and figure out what you want to keep and what you want to get rid of. Because like our commit we just reverted was simple. It was just get rid of a line. But if you're reverting something from a while back and Git doesn't know what to keep and what not to keep, you have to do it yourself. You've got to go into the files and resolve the conflicts and then make your commit manually. But the end result is the same. Okay, so that's git revert. It will undo a commit by making a new commit that undoes the changes. All right, so next up, another exercise, another opportunity to practice things. And this section covered quite a few different commands. They all, or almost all, started with an R, right? Reset, restore, revert. Maybe it was just those 3, but it just felt like a lot of R's, and they all sound similar. You'll get a chance to practice some of them here. This exercise is going to cover most of what we talked about. And I did say I wouldn't expect you to just immediately remember them all, so please feel free to reference notes, Google things. I mean, you should always do that. It's just part of the process. Anyway, this exercise is another one that is asking you to download an existing starter repository. So I still realize we have not really covered clone. You've cloned at least one time in a prior exercise. This is another example where I'm just going to ask you to run this command and just trust me, it gives you a repository I've made for you. We are on the verge, the cusp of learning about git clone. But for now, just run this at the beginning. So as always, this link is available as a resource with this video. I highly recommend you do the exercise. I think it's kind of a fun one. It's based on the lyrics to the Beatles song Yesterday, which originally Paul McCartney wrote the melody and he sang it in his head and to friends using scrambled eggs. And then there's a whole bunch of lyrics he actually wrote that are all based around scrambled eggs. So the history of this repository actually includes my fictionalized evolution of those lyrics. So you'll see if you clone this repository, we'll start there, make sure that we're not in a Git repository when we do this, and then just paste that line. Okay, that now makes us a folder called Yesterday Exercise. So if we cd into that, the next step is to, well, we should see a file called lyrics, okay? And then we take a look at the commit history. So I'll just do that with you right now. Let me do one line. You can see that there are 8 different commits that you have already just by cloning. So this first kind of batch here all have to do with scrambled egg lyrics. So I copied and pasted, but the original first verse, second verse, the chorus, then I finished it. And then this is the rework where it became yesterday instead of scrambled eggs, broken into 4 different commits. Okay, so your task is, well, there's a bunch of tasks, is to follow the instructions. I won't just walk through them all right now before I do it, but basically at one point I ask you to go back and check out a commit. You'll go into detached head, and then I ask you to go back, leave detached head, go back to the master branch. Then I ask you to go find a particular commit where I finish the original lyrics and then create a branch based upon that commit. So that we'll have one branch called Scrambled Eggs that actually has all the lyrics from that original version called Scrambled Eggs. And then I'm going to ask you to make a serious change, delete everything in the lyrics.txt file, and then save that file. But don't add and commit, just save. And then using a git command, so not using command Z or undo, but using a git command, discard those changes you made so that you end up with the lyrics back in the file. Then we move on to something slightly humorous, where I found some parody lyrics from this website. I did not write these myself. And these parody lyrics have to do with 404 pages. So lyrics set to yesterday, but about 404 pages. So I just ask you to copy some of them, paste it into the lyrics file, and add and commit on the master branch, and then do it again. Finish the song out, add and commit on the master branch. After more consideration, you realize you don't actually want those 2 commits on the master branch, so I would like for you to move them. And the way that we'll do that is by undoing them. So we're going to remove those 2 commits from the master branch. We've seen a command to do that. However, I don't want you to lose those changes. I want you to keep the changes in your working directory. So you may need to rewatch a video to learn how to do that. Keep the changes, undo the 2 commits. Then you can create a new branch called 404, switch over to it, and then those changes will come with you. You can add and commit them on the 404 branch and go back to the master branch, and we'll have the original lyrics. So don't just, listen to me, read the exercise, read the bullet points. I think it's pretty step-by-step. You'll need to use most of the commands we talked about, and you may need to reference either the Git docs or the earlier videos in this section. So I'm going to go ahead and do it. I really recommend you do it. It kind of takes me forever to make these things, so I hope you get something out of them. Anyway, here we go. So I already cloned. We already saw that there was 8 commits in there. I'm going to check out the very first commit. And first, I'm just going to open up the lyrics file, right? There's one file, so I'll just open it up in VS Code. And I'll do this side by side. Okay, so there is the lyrics, the complete lyrics for yesterday. Although actually I did leave off the final verse. Anyway, what we're going to do now is go back to the commit. That was the very, very first commit. So git log, just do one line. And I'm going to copy this hash and then check it out. Git check out that hash. And this is the very first commit. We are going to immediately leave. We saw those lyrics, right? Those are different than what was just in that file. We're going to go back to the master branch. So I can just do a git switch master or just git switch dash to go back to where I was. And now we see yesterday, the actual lyrics. Next, go back to the commit where the original version of the lyrics was first completed. This commit has the message finish original lyrics, and then create a branch called Scrambled Eggs based on that commit. So we'll do a git log, one line. Let's find, there it is, finish original lyrics, copy that hash. We're going to check it out. This will be a detached head, which is okay. So here's the full scrambled eggs lyrics. So we're going to make a branch based upon this. I'm going to switch to it. Let me clear -C, and it's called scrambled eggs. So now we're no longer in detached head. We have these changes from the earlier commit, but I can also switch back to master, and we don't have those changes here. I mean, we do in the history, but currently in the working directory, we don't. Now, delete everything in the lyrics file on the master branch and save. Uh-oh, I didn't mean to do that. And ignoring the fact that I can just do Command Z and undo it, using a git command, discard those changes. Okay, how do I do that? Well, there's a couple of options. The newer way of doing it is git restore and then a file name. So git restore lyrics, and there we are. But I can also recreate that. So I just saved again. I can do the older version, whoopsies, git checkout head, and then the file lyrics. And there we go, same thing. Okay, next up, I get a creative itch. I'm on the master branch. I'm gonna replace the contents of the lyrics file with this. Nope, not that, I copied the wrong thing. This. And we're going to add and commit this on the master branch. So git add lyrics, git commit, just go with begin 404 lyrics. And then we're just gonna copy this, the second half of the song, put it at the bottom of the file, and then add and commit again. So git add lyrics, git commit, finish 404 lyrics. And then we realize, oh, that was actually a mistake. Shouldn't have done that on the master branch. I don't even know if I want those lyrics anymore. So I'm going to move them to a branch called 404, but I already made the commits on the master branch. So I'm going to undo them on master. So I need to use the reset command, and I need to figure out where I'm resetting back to. So this is 404, this is 404. This is what I want to go back to. So 2 commits ago. Copy that hash, and then I'm going to do a git reset, but I'm not going to do hard, if you recall, which also updates the files and undoes the changes. It doesn't just delete the commits, it actually undoes changes. I'm not going to do that, as this document makes, I hope, clear. Keep the changes in your working directory. Just undo the 2 commits. Okay? So we don't see anything change over here, but if I do a git log, we don't see those 404 commits. So now I can make my new branch called 404. So git switch -C 404. And those changes come with me. If I look at git status, right, it says you modified the lyrics file. So now I can add and commit on this branch. Git add lyrics, git commit. I don't know, how about write 404 parody lyrics. Jeez, can't type. Okay, so that's on the 404 branch. And now I can switch back to master, right? Here's the 404 lyrics, but on master, they're gone. We have the original yesterday lyrics, right? We don't have that 404 commit. This is the final thing on the master branch. And if we switch back to 404, we have those lovely parody lyrics. And if we switch to scrambled eggs, which is the other branch that we made early on, I have the original scrambled eggs version of yesterday. And that's it for the exercise. Okay,